My dear friends, today I'm going to explain what is a potentiometer, what is a potentiometer, and what it is principle and is working. Okay. First of all, learn that potentiometer it is an apparatus. If it is an apparatus, mean it is having some role. Okay. And what is the role of this apparatus? Its role is measuring the EMF of a cell. You know, if this is a cell, right, and it is having some EMF. EMF means if you measure, it is it is in a circuit, but this circuit is off. This circuit is off. No current is flowing because circuit is off. And you measure the potential difference across the cell. And whatever will be the potential difference, you will call it EMF. Okay? If no current is flowing. That is called EMF of the cell. Mean EMF is basically maximum potential difference as no current is flowing. So this potentiometer, it is used to measure EMF of the cell. This is the role of the potentiometer. Now I am coming to the construction. So first of all, a potentiometer consists of a long uniform wire generally made of manganese or constantan. So what's mean? The mean is, this is our potentiometer. Now here, note that between this point and this point, this is A point, this is B point, there is a long wire from here to here, here to here, here to here, here to here. This length is 100 meter, again 100 meter, again 100 meter, again 100 meter, 100, 200, 300, 400. So zero length is here and 400 centimeter is here. So this is a long wire of 4 meter or 400 centimeter in length. Okay. So it is clear. It consists of long uniform and it is made up of this. The material of this wire is, which is the material? The material is manganese. And the one question for you, why manganese? You give this answer and write the answer in the comments box. Okay. And second, it is a uniform. Uniform means the thickness of the wire should be same everywhere. Okay, that's the meaning of the uniform. So this line is clear. Now then, the potentiometer is provided with the jockey. Before coming to the jockey part, okay, now I written here a battery of EMF E called the driving cell connected across A and B, send the current through the wire which is kept constant by using a rheostat. So what the meaning of this line? It is very important. So in this potentiometer, this circuit is basic from here to here. This is basic circuit where there is a cell, there is an ammeter, there is a rheostat, there is an off-on key. This cell is called driving cell and it is of EMF E. Okay, don't confuse with the aim of the potentiometer to measure the EMF of a cell. This is not that cell whose measurement is taken. No, this is not that cell. That cell will be different. this is a driving cell. This is a basic cell which we have to connect. We are not going to measure the EMF of this cell. Remember, that's why it is called driving cell, because it will send a current in this wire. So this is a basic cell, driving cell. This is a rheostat. What is the function of rheostat? To increase or decrease the current which is given to the potentiometer. You can adjust the current, and whatever the current you will adjust, you will measure it through this ammeter, and this is off on key. So this is a basic circuit and it is there always. What is the function of this circuit? Tell me again. Its function is only to send the current through the potentiometer wire. Okay. Now then, after that, what is this? This is a strip and it is made up of copper. This is a strip made up of copper. Why copper? Because copper is having very low resistance. Approximately, we assume it is resistance of the strip, it is 0. Now, this is clear basic circuit and a wire and copper strips. Now, then there is a meter scale, just to note down the length of the potentiometer wire, to measure the length. Now, then you note down there is a voltmeter is connected here. And then there is a wire. Now, what is the mean of this? This wire is not connected with this. This wire is not connected with this. And at the end of the wire there is a jockey. Jockey means like a pen having a tip, metallic pen. And you can touch on the wire with the help of the jockey anywhere. So this is all about the construction of the potentiometer. Now very simple, wire, meter scale, basic circuit to send the current, voltmeter is connected here and the jockey. Okay, now coming to the mathematics. Mathematics is very simple. You know very well, V equals to IR, and the resistance of the wire is rho, resistivity L upon A. A is the area of cross section. Substituting it here, and V becomes I rho L upon E. Okay. Now if I is constant, rho is constant, area is constant. Now this V is equals to K into L. This voltage is proportional to L. K is constant. What is K? K is I rho upon A. Okay. This is the principle of the potentiometer. That, coming back to this apparatus, as the current, starting here, as the current is flowing, okay, and this principle tells us that voltage is proportional to L. If you touch the jockey at here, then this will give a small voltage. If you touch the jockey at here, then because the length is increased, it will show more voltage. If you touch the jockey at here, even then now there will be more voltage because length is increased. If you touch the jockey at here, there is 100, 200, 250 centimeter, then more voltage. And if you touch the jockey here, even the voltage will still increase. So voltage will go on increasing as you touch the jockey, like I am touching jockey like this on the wire. What happens? The voltage will go on increasing. The voltage is increasing. This is the principle of the potentiometer. Voltage is proportional to L. Okay, but keep in mind, I should be constant. How I is constant? With the help of the rheostat. Okay, we will note down I should not change. Then rho is constant because wire is of a given material. So rho is constant. A is constant because this uniform wire, uniform means area of cross section constant. So this is the principle of the potentiometer. Okay, like that here, if you read it from your book, the fall of potential means the voltmeter. Fall of potential means this voltmeter reading. Okay, means when the potential develops here, where you touch the jockey. So you touch the jockey here, so potential develops on the wire. The potential develops on the wire is called the fall of potential. So fall of potential across any portion of the wire, is directly proportional to length of that portion of the wire of uniform area of cross section and when a constant current is flowing through it. Okay, so this is your principle and K is constant. And sometimes, like V equals to K, and we may write it V upon L is equals to K. V upon L means potential or voltage developed per unit length. Okay, and voltage developed per unit length on the potentiometer wire remains constant. So this is all about the potentiometer. Okay, if you come across any difficulty regarding the potentiometer, please don't hesitate. Write me in the comments box. I will definitely give you the answer. My phone number is 9888 169 226. Okay.